In this case, I'm trying to find the equation of the secant line of g of x equals x cubed plus 2x squared on 0, 5. And I want to find the slope. So I start by knowing that the slope of the secant line is the same thing as the average rate of change. So I'm looking for the change in g over the change in x. I have g of 5 minus g of 0 over 5 minus 0. So I plug in and evaluate g of 5 and g of 0 and look at the difference and look at 5 minus 0. And then if I actually calculate that out, I get 35. So now there are multiple ways you can proceed. How many of you prefer point slope form? How many of you prefer slope intercept form? Okay, so if you want to use slope intercept form, you can start out with y equals mx plus b. And I already know that my m here is 35. Now, how do I get my x and my y to solve for my b? No worries. Well, the x and the y are going to come from a point on the curve. And the point on the curve, of course, comes from just plugging the x value into the function. So I know that when x is equal to 0, y would be equal to 0 cubed plus 2 times 0 squared, which is also 0. Yes, so my point here would be 0, 0. And so I look here and I say, well, wait a minute, that's already the y-intercept. But if I didn't see that, I could say, well, 0 equals 35 times 0 plus b. 0 equals 0 plus b. So 0 is equal to b. And if I take this calculation and plug it back in for b, I get the final answer, which will be y is equal to 35x. So really, it's not any different than any other linear calculation that we do. It's just that the slope is going to come from average rate of change, and the points that we need to plug in to get slope intercept form will be coming from plugging in the function.